Joining us once again are Thomas Wire and Gregg Wong, who many of you are already familiar with from our prior interviews. And today we are going to do a deep dive into all things ground testing. Gregg, we'll start with you, brother. How have you been? And can you tell our audience a little bit more about yourself?
Sure. My name is Gregg Wong. I am AEMC's technical training supervisor, and it's my job to run around the country and teach everyone a little bit more about ground resistance testing and how to perform it accurately when it matters. We also teach seminars on insulation resistance testing and other subjects around any of the instruments that AEMC Instruments manufactures.
Kind of like that one that Tom's got right there.
Friendly megometer.
And the nefarious Thomas Wire. Sir, how you been? And can you refresh our audience to a little bit more about yourself?
Nefarious is a generous name. Micah, it's good to be here again. Tom Wire, Risa Power, senior technical trainer. I like to travel around the country as well and train our guys at various locations on how to do all things that need a test technicians do.
That is fantastic. And as mentioned in the intro, we are here to discuss ground testing until you're tired of hearing about ground testing. And so with that being said, I'll kind of throw out just a generalized start to the conversation here. So what are some of the concepts for why we even have ground testing? And I'll turn the floor over to you guys on that one.
Yeah, so, this question comes up quite a bit is why do I have to do this measurement? And we see it done in various phases that we're all somewhat familiar with. We have the acceptance testing or proof testing. I've just installed this. It's just been built and I need to verify its resistance to ground, whatever it may be, some electrode system. And then there's, of course, other testing that may fall into the category of ground resistance testing. And then there's maintenance testing. And I think a mistake that is oftentimes made by individuals, even inside the electrical testing industry and definitely outside of it, is that we pound this ground electrode into the ground and we don't see it anymore. And so if we can't see it anymore, everything's fine, right? It's working. And this is not some system that is oftentimes, hopefully not utilized very often. So we don't necessarily see any type of performance issues that are related to the ground electrode and its resistance to ground. So why is it that we have to perform this? Well, let's remember, first and foremost, we're pounding a metallic object into the ground. When we do that, we may cause some type of damage to its copper coating, right? Usually electrodes are copper clad. And when we pound this thing into the ground, it gets scratched up by nearby rock and other types of materials that are hard on it. It then begins to corrode, and it will corrode maybe exceedingly faster than it would have otherwise. So we are introducing this object into the ground. It's going to experience some type of stress. And that stress can cause it to fail, whether it be prematurely or otherwise. Let's also remember, too, ground electrodes have a lifespan. And depending on where you're located, that lifespan is going to be dramatically different. If I drive a ground rod here, where I'm at in North Texas, that is galvanized, for instance, it doesn't have a very long shelf life in the ground. Or I should say shelf life, service life. Versus a ground electrode that may be pounded in a completely different part of the world, it is going to perform much, much different. It's going to last longer. We have very low resistivity soil here in North Texas, so we have a lot of issues with galvanic corrosion. So these systems, they can fail. And humans, of course, can cause these to fail too. Everybody's got the same story of the guy with the excavator or the landscaper that tears up a ground electrode or a ground electrode bond, or ground electrode conductor. So these things are not just installed, set it and forget it type devices or objects. We have to continually test them to validate that they are of a sufficiently low resistance to earth, to make sure that they are going to work when that time comes.